Hey guys, it's Mr. Walker here, and thank you for joining me for yet another math lesson with Mr. Walker. In this lesson, we're going to be building on what we've done in some previous lessons, not only talking about the strategies that we've used to add and subtract fractions with unlike denominators, with unlike units, right? And now we're going to specifically focus on subtracting fractions, making like units. So that means that the fractions that we're subtracting, they don't have the same units, they don't have the same denominator. So we're going to have to make like units, and we're going to use a new strategy, one that we've used with addition. Now we're going to use it with subtractions, and we're going to start moving away from drawing out those pictures and making those equal units and dividing them up that way, and we're going to use numbers this time. We're going to start doing it numerically, okay? So we're going to take a look at a few examples. All you really need today is something to write on, something to write with, and then we'll get rolling. So make sure you have those things, and then click continue when you're ready. Alright, so I'm going to jump right in here with an example, okay? So let's say we had something like this. We had 1/3 and we were subtracting 1/5 from it, okay? Previously, what we've learned, strategies for doing this, is we would draw out some of these like rectangular shapes, right, to kind of visualize the fraction here. So what I would do is I would divide this fraction into thirds, right? So I have 1, 2, 3. And I have one of those thirds. We'll come back to that in a second. I'm going to divide this fraction into fifths. Right? So we'll do this horizontally. 1, 2, 3, 4, 5. So there's my fifths. Here's my thirds. Good enough there. Let's draw now with the actual fraction that we're representing. So we're representing 1/3. So I'm going to color in one of these thirds. And over here we're doing 1/5. So I'm going to color in one of these fifths, all right? And what we're going to have to do is, and we kind of saw this in a previous lesson, we're going to have to take these thirds and we're going to have to split them 5 times, right? To get those equal units there. So if I divide, or I should say divide, if I split this in 5 times, so 1, 2, 3, 4, 5, right? We're going to get some units here. Then I'm going to take my fifths and split them 3 times. So we'll do 1, 2, 3. So now I should have some like units. Over here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 units here, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 over here. So if we look at what we have made, I have 1, 2, 3, 4, 5, 5 15ths here, and I have 3 15ths over here. So I made some equivalent fractions. 5 15ths and 3 15ths. And I could subtract these now because I would simply, from my 5 15ths, I'm going to take away 3 of those 15ths. 1, 2, 3. That's going to leave me with 2 15ths. Easy enough, right? But instead of doing this by drawing out all these pictures and stuff like that, let's see how we could do this numerically like we did previously with addition. So I'm going to take this whole example, shrink it down. I'm going to move it over here so we don't forget about it. We can reference it if we need to, but I want a little more space to write down here. So I have this 1/3 and I have 1/5, right? And when we took our 1/3, we split it 5 times, right? 5 times as much. 5 times. And 1 times 5 gave me 5. 3 times 5 gave me 15, which is what we ended up with over here. Our 1/5, we found that common unit of 15, right? We split our 1/3 into 15ths. I'm going to split the 1/5 into 15ths. So 5 times 3 gave us 15. 1 times 3 gives me 3 15ths, right? Because we had to split it into thirds. So we multiplied it by 3. I know when you hear me say split it into thirds, but we had to split it into 3 times. So you might think split into thirds, that means divide, but it doesn't mean divide, it means we're splitting it 3 times, okay? So I'm sorry if that explanation confuses you, but we'll get the hang of it as we go. So now we have these two new fractions of 5 fifths, or 5 15ths and 3 15ths, and again, if we were to subtract those, 5 minus 3 would give me 2 15ths, okay? So we could do the same sort of thing when we're subtracting. It's not any different. We're going to follow the same steps as we did with addition. We're going to find that common unit, and then we're going to be able to subtract. Let's take a look at one more example real quick like this, where we're going to take 3 fifths and I'm going to subtract 1/6 from it. Again, if I wanted to think of this, I could try to think of multiples, right? Like 5, 10, 15, 20. So far, I'm not seeing any that 6 will have in common, because 6 is 6, 12, 18, 24. So I'm not getting any here. So what I'm going to do is I'm just going to multiply them by each other. So I'm going to take that 3/5. I'm going to times it by 6, right? Because we'll be splitting, if we think of back to that rectangle again, we're going to take our fifths, and we're going to split them 6 times. 1, 2, 3, 4, 5, 6, okay? So if we did that, 3 times 6 would give me 18. 5 times 6 would give me 30. So 18/30ths, right? If we did our other fraction here of 1/6, multiply it by 5, because again, if we had that rectangle and we had our sixths, I'm going to be splitting it 5 times, okay? And that I'm going to do that to both my numerator and my denominator. 6 times 5 would give me 30, right? Because the units are going to match. 1 times 5 would give me 5, and we're good to go. So I have 18/30ths minus 5/30ths. Let me just rewrite this up here. 18/30ths minus 5/30ths, which is going to equal 13/30ths. Easy enough. Okay, so we were able to get the same answer, get the same thing. We didn't have to draw out the pictures, even though I sketched them out really brief down here to kind of illustrate our point. We didn't have to use that to get to the same spot. All right, let's take a look at one more example that we might encounter, and I'm going to show you actually 3 different ways that we could solve the same problem. Pretty crazy, right? So I'm actually going to list them here. I'm going to do method 1, do method 2, and over here we'll do method number 3. Cool. All right, so let's say we had something like this. We had 1 3/4, and we were going to subtract 3/5 from it. What's that going to equal? So as you can see, we have definitely more than a whole here, and then a fraction here. So what we're going to take a look at real quick is a couple different ways that we could solve this problem. So first of all, I can kind of think about this 1 3/4. I could think about it, I could split it into to 2 numbers, right? I could think of this as 4/4, my 1 whole, I could think of as 4/4. And I could think of my 3/4, of course, as 3/4, and then minus 3/5, right? But here's the thing, I have fifths over here. Instead of thinking of my 1 whole as 4/4, could I think of it as 5/5? Would that be the same thing? Yeah, it totally would, right? And then I could have those units the same right off the bat. I wouldn't even have to do anything else. So instead of thinking of it as 4/4, I'm going to think of it as 5/5. And now I can do 5/5 minus 3/5, which would give me 2/5. So now I have 2/5 minus 3/4. That's all I'm left with, right? Got rid of this guy, got rid of this guy, and that's what I'm left with. So now I could subtract these. I have to think about what's going to be my common unit that I could use. So if I count by 5s, 5, 10, 15, 20, 25, all right, thinking about 4, the only one I know that they have in common is going to be 20. I'm actually going to spread these guys out a little bit to give myself some room to work. So let's see. I'm going to have to get my 2/5 to something out of 20, my 3/4 to something out of 20, because we know that that's a multiple that they have in common. So 5 times 4 would give me 20. 2 times 4 would give me 8. 4 times 5 would give me 20. 3 times 5 would give me 15. So now I have 8/20ths and 15/20ths. And before I said we'd have to subtract them, and I misspoke. We already subtracted. We subtracted that 3/5. We took it away from the 1 whole. We're good there. So these two numbers, we're actually going to add them together. 8/20ths and 15/20ths, which would give me 23/20ths, which is the same as 1 3/20ths. Okay, so that's going to be our answer. So 1 3/4 minus 3/5 is 1 3/20. Okay, so that's method 1. You can think of that whole number. match it up to whatever unit you're subtracting, and then go through that way. Okay, let's take a look at method 2 over here. Method 2, I could kind of split up that 1 again, and I could just let him hang out over here, so I could think of it as 1 plus my 3/4, right? Because 1 plus 3/4 is 1 3/4, and then I could subtract that 3/5. So I'm just going to really think about my 3/4 and my 3/5. I'm going to make those equivalent fractions, those fractions with the same unit, right? Which is what I did over here. So my 3/4 is going to change to 15/20. My 3/5 is going to change into 12/20. Okay, because 4 times 5 would give me 20. 3 times 5 would give me 15. 5 times 4 would give me 20. 3 times 4 would give me 12. Okay, so that's how I got those two there. I gotta subtract these guys, and I can still leave this 1 kind of hanging out by himself. So 15 minus 12 would give me 3/20. My 1's still there, so I'm going to have 1 3/20. 1 3/20. 1 3/20. Ooh, same thing, just a different method to get there. Okay, this one I kind of left the 1 by himself. I subtracted my fractions first, and then we're good to go. And my last method over here, this one is kind of the one I think I use probably most often, and that is to turn my mixed number here, my whole in a fraction, into what we commonly refer to as an improper fraction. But we don't have to think of it as improper. There's nothing wrong with it. It's just a different way of representing it, right? So if I think of this 1 3/4, if I think of it as 4/4 and 3/4, that really is the same thing as 7/4. Okay, so I have 7/4 minus 3/5. Okay. So if I'm going to change these two guys to something out of 20 and something out of 20, 4 times 5 would give me 20. 7 times 5 would be 35. 5 times 4 would give me 20. 3 times 4 would give me 12. So I have 35 minus 12/20. And when I subtract those two guys, I'm going to get 23/20, which is, oh, look in here, same thing I kind of had over here, which is still going to equal 1 3/20. 1 3/20. Sorry, my 3's aren't turning out real good, but you get the idea. So this is 3 methods that we could use to subtract fractions and whole numbers, but regardless of what method you use, we're still going to have to find that common multiple, right? The common denominator that all of these numbers have. We're going to have to get it to that number, whether you're going to draw it out visually, okay, which you can totally do, but you can start to think about it numerically, okay? What number do they have in common? Here we knew it was 20, so I just had to multiply whatever my denominator was by whatever number it took to get it to 20, okay? So hopefully this is starting to make sense. If you guys need any more practice with this, of course we're going to practice this in our module work, but if you need any more practice, if you have any questions, comments, or concerns, please reach out, let me know. Reach out to me, reach out to a learning guide, reach out to a teacher, get the help that you need. But I do appreciate you guys watching along and paying attention with me, and I hope you got something out of it. So thank you very much, guys, and we'll talk to you soon.